In today's lesson, toda kuita this particular question. Question yacho iri kuti a sequence u1, u2, u3 is defined by u1 is equal to 2 and un plus 1 is equal to un plus 3 for n greater than or equal to 1. Part 1 iri kuti write down the first 4 terms of the sequence 1 mark. Kurati tofangwa kuita typically in a minute or under. Saka kuti tite part 1 tatoudzwa already kuti u1 is equal to 2, but kuti u1 ndiko kuti a, because a inomirira the first term and this is equal to 2 like that. But taudzwa kuti u1 is equal to 2, tazopiwa that relation kana kuti that equation iri kuti un plus 1 is equal to un plus 3. Truda kutsvaga chi? Part 1 iri kuti write down the first 4 terms of the sequence. Saka first term tatova nayo anova 2. Takuda kutsvaga the second, third and fourth terms. So kuti tiwane the second term, tichati when n is equal to 1. N kana equal to 1, tikada kusubstitute 1 is tikada kusubstitute panapa pana n tichisa 1 inova chi u1 plus 1 is equal to u1 plus 3. Saka u1 plus 1 ndiyo chi u2, which is the second term, is equal to, then for u1 to substitute ana 2 since tatoudzwa kuti u1 is equal to 2. Saka panapa is 2 plus 3 kureva kuti u2 inenge iri equal to 2 plus 3 which is 5. Saka natada iso tinenge tatowana u2. Ngatichitsvaga mamwe sekurayirwa kwataitwa. Saka kana takuda kuwana u3 and u3 yacho tenge tamboinyora iri chi u2 plus 1 andika kureva kuti tenge tati when n is equal to 2. So let us do just that. Saka takuti when n is equal to 2, u2 plus 1 is equal to u2 plus 3. u2 ta calculate tikaona ari 5, so 5 plus 3, 5, 6, 7, 8. Kureva kuti the third term is equal to 8. Now for the fourth term, tinoti when n is equal to 3, kureva kuti ichava u3 plus 1 is equal to u3 plus 3, which is equal to, what is u3? The 8. So 8 plus 3, 8, 9, 10, 11. That is going to be our fourth term. Therefore, u1, u2, u3, u4 is equal to, totangane the first term which is 2, saka 2, 5, 8, 11. That is going to be our final answer. That is where we find the 1 mark. Write down the first 4 terms of the sequence. Tamanyora ndi 2, 5, 8, 3. But before taenda kure, can you see that this sequence is actually going to be an arithmetic progression? And the common difference is going to be 3. Because for every successive term, tiri kuedda 3. Saka panapa tatora the first term tikati plus 3 tikaona 5. Ndokunotora the second term 5 tikati plus 3 tikaona 8. Ndokunotora the third term 8 tikati plus 3 tikaona 11, which is the fourth term. Saka the common difference in this arithmetic progression is going to be 3. Tada iso tinenge tatopedza the first part of our question. The second part of the question iri kuti state what type of sequence it is and express un in terms of n. It has 2 marks. Saka pakuti state what type of sequence it is, answer yenyu panapa inenge ingori arithmetic progression. Sekutaura kwataita munogona kuprova kuti it's an arithmetic progression. Muri panapa d inenge iri equal to preceding term 5 minus preceding term 2 which is 3. Mukati futi 8 minus 5 munowana 3. Kana kuti mukati 5 plus 3 munowana 8. Mukati 8 plus 3 munowana 11. Saka d yenyu inenge iri 3, your common difference. So pari kunzi what type of sequence it is, answer yenyu inenge ichiti arithmetic progression. Then apa pari kuzonzi express un in terms of n. Un in arithmetic progression, the nth term in an arithmetic progression is equal to a plus n minus 1 multiplying d. But a tikuziva kuti ndiani, tamupiwa in the question ndi 2. So this is going to be 2 plus n minus 1. Common difference yenyu matoona kuti ndiani, ndi 3. Saka question yati express un in terms of n. So since iri in terms of n, if we simplify this, we get our answer. So this is equal to 2 plus, then panapa we remove brackets, 3 times n, that's 3n, 3 times minus 1 di minus 3. Takati 2, in fact tokononyora takati 3n and 2 minus 3 di minus 1. So this is going to be your answer. In terms of n, 3n minus 1. That is how you do it. It's as simple as that. Okay, let us now go to the last part of our question, but let me clear the board. Looking at this particular question, a geometric progression of positive terms is such that the sum of its first 2 terms is 24 and the third term is 2. Find the common ratio and the sum to infinity of this progression. A geometric progression of positive terms. So we have a geometric progression, and it's important kuti of positive terms is such that the sum of its first 2 terms is 24. Saka mistake yandakatomboita on this question inoita lead to a loop. Kutora statement iri rakanzi the sum of its first 2 terms is 24 mova maridai. So in fact monyora makadai makati s of 2 is equal to 24. Then since iri gp mozozama kuti a 1 minus r to the n over 1 minus r is equals to 24. Mathematically speaking, this is correct, this is accurate, but it loops because it overcomplicates the question. Instead, if you want to mathematize this part of your question, what you rather do is this. And ndoda kuti zvimuziite for every question. Kana muchieda 2 consecutive kana kuti 2 following terms, matema ari kuteverana. Pakanzi the sum of its first 2 terms is 24. Kana iri geometric progression tinenge tiine r, but r yacho inoshanda sei? Tinenge tichiti tikati first term times r inotipa second term, second term times r yotipa third term. Saka the common ratio r inenge ichimultiply a previous term kuti tiwane a term which comes after it. Inenge ichimultiply first term kuti tiwane second term. Kureva kuti pano kana first term yedu iri a, zvoreva kuti second term inenge iri a r. I hope you understand panapa, because common ratio r ino multiply first term kuti itipe second term. Deno yanga iri ap, common difference d ino add ku first term kuti tiwane second term. Saka for an ap, a anenge ari first term, a plus d anenge ari yechi second term. So first term is A, second term is AR. If you don't understand this, tokerai ku lesson ratakaintroduce geometric progression. We explained this patakanyora a general sequence of a geometric progression kana kuti geometrically progressing sequence. So first term A, second term AR. Ndokuudzwa kuti the sum of its first two terms is 24. Kureva kuti A plus AR is equal to 24. This is equation number 1. Ndobva zvazonzi and the third term is 2. Saka third term is equal to 2 like that. Find the common ratio, correct, find R and the sum to infinity of this progression. Saka tikada kutanga tasolva the first part yakati find the common ratio. We know kuti nth term for a GP is equal to AR to the n minus 1. And let me box this formula that we know. Kureva kuti third term ino ishi inenge iri equal to A tikuizivera tizi and R tikuiziva zvakare. Then 3 minus 1 is equal to 2. Kureva kuti AR squared is equal to 2. That will be our equation number 2, like that. Saka takuda kushandisa equation 1 and equation 2 in a simultaneous situation kuti tiwane R, since zvanzi find the common ratio and then tozoshandisa R na A kucalculate sum to infinity. So how are we going to do that? Let me put all these equations pan 1. A plus AR is equal to 24 like that. And then this is equation 1. AR squared is equal to 2. This is equation number 2. Now that we have these two equations, A plus AR is equal to 24, na AR squared is equal to 2, we are going to solve the two equations simultaneously. Saka tichada kushandisa a method of solving simultaneous equations, which I call the method of equivalence. Yatinozoshandisa a law of logic, which is called transitivity. So if you want to learn more on this method of equivalence, you can tell me in the comments and I will direct you to a link where we taught simultaneous equations at ordinary level. Saka takatarisa ma equations atinawo ari 2. We have to simplify them a little so that we can use them properly. Saka tikatora the first equation we have, A plus AR is equal to 24. Tika factor out A, tinosara tina A 1 plus R is equal to 24, and this is just equation 1. Equation 2, AR squared is equal to 2, that's equation 2. Then tikatarisa ma variables atinawo in those two equations, tina A, tina R. Because R in the second equation, ana squared, because in the second equation we have AR squared, it is easier kuti tiite make A subject of formula in both equations. Saka A is the subject of formula in the first equation. A ananga equal to 24 over bracket 1 plus R. Like that. This is equation 1. And then in the second equation, A ananga equal to 2 over R squared. This is equation 2. Saka tikadai so tinenge taita make A subject of formula. Now this law of logic inozi transitivity inoti, if A is equal to B and A is also equal to C, that means B is equal to C. In layman terms, kana A are equal to 24 over 1 plus R, A cannot the same A are equal to 2 over R squared, that simply means 24 over 1 plus R is equal to 2 over R squared. So that is what we are going to be using here. Saka, what are we going to solve apo? We are going to solve this 24 over bracket 1 plus r is equal to 2 over r squared. That is what we want to solve. Then through cross multiplication, 24 times r squared ichava 24r squared. This is equal to 2 times the bracket 1 plus r. Saka patiri kuti 24r squared is equal to 2 times 1 the 2 times r, that's plus 2r. Then pakadai so we can make this a quadratic equation by getting 2 na 2r ku left hand side. Saka 24r squared minus 2r, it becomes minus because iri kubva ku right ichienda ku left, crossing the cosine. The same effect pana 2 anova minus 2. This is equal to 0. Now we can further simplify this quadratic equation by dividing by 2 throughout. So tikadivide na 2 panapa, apo na 2, apo na 2, then apo futi na 2. 2 into 24r squared the 12r squared. 2 into minus 2r the minus r. 2 into minus 2 the minus 1. And this is equal to 2 into 0, that is 0. Padai so we multiply the first and the last terms. 12r squared times minus 1 the minus 12r squared. We have to get factors of minus 12r squared such that tikama multiplier ma factors are 2 anotipa minus 12r squared, tikama adder anotipa minus r. Saka we are going to deal with 4r na 3r. We know that 4 times 3 is 12. 4r times 3r is 12r squared. But we need to multiply 4r na 3r, getting minus 12r squared. At the same instance, we have to subtract or add 4r na 3r to get minus r. Saka if we make 4r a negative and 3r a positive, minus 4r times 3r d minus 12r squared. A negative multiplying a positive gives a negative. Minus 4r plus 3r is evidently minus r. So because of this, we can now solve this quadratic equation more easily. So let us do this. We are going to substitute, as usual, the middle term minus r with minus 4r plus 3r. So this becomes 12r squared minus 4r plus 3r minus 1 is equals to 0. Then we group using brackets like this. What do we factor out from the first bracket? We factor out 4r. Tichasara t nani. Saka it is 4r times 3r, which gives 12r squared. And it is 4r times minus 1, which gives minus 4r. Then from the second bracket, we factor out 1. So plus 1, 3r minus 1. This is equal to 0. To mean, panapatana 4r plus 1. We take my terms are kunze and form a bracket. Panotina 3r minus 1. This is equal to 0. This means 4r plus 1 is equal to 0, or 3r minus 1 is equal to 0. Saka 4r ngari equal to chi. Saka from the first equation 4r plus 1, r ngari equal to chi. So tenge tichingoti 4r plus 1 is equal to 0, which means 4r ingeri equal to minus 1. Saka r is equal to minus 1 over 4. This is the r we get from the first equation. Then from the second equation, let me just put in an answer here. R ngari equal to a third. R will be equal to 1 over 3, because minus 1 panoenda ku right hand side anosvika ari positive 1. Then we divide both sides na 3. Saka ma RT now we have two values. Tina minus 1 over 4 now 1 over 3. So how are we going to decide which one is the true value? Kuti tiunderstande kuti r watiri kushanda naye ndeupi, we have to go back to the question. Tikadzokera question, panzi a geometric progression of positive terms. What does it mean kana tichiti a geometric progression of positive terms? So let me show you illustratively what it means. So I'm going to write down zvanzi a GP of positive terms. Zvinorevei kuti a GP of positive terms? That's the question we want to answer. Saka we know that generally speaking, a GP is more like this. Tina A, then we multiply A, which is the first term, na R, kuti tuwane chi AR. Then we do the same times R. The second term tika multiply ne common ratio, which is R. Tinowana the third term AR squared. And we are going to do that AR cubed and so forth. So what is happening here is toda kuziva kuti R wedu anenge ambori chi, because tapiwa R aine ma values 2. It's either it's negative quarter kana kuti it's a positive third. But isusu manje, because taudzwa kuti our geometric progression is made up of positive terms, zvinoreva kuti it's not possible to take negative R, because kana R yakava negative, so that second term inenge iri futi negative. Saka R akava for example negative quarter, so that A, which is our first term, second term yedu inenge iri chi, inenge iri negative A over 4. Because it's A times R, inenge iri A times negative quarter. And then our third term inenge iri chi, negative A over 16, more like this. So we cannot take R as negative quarter, because tikatora R iri negative, GP yedu is just made up of positive terms. Kureva kuti, as in our final answer, tengeta kungoti therefore R is equal to 1 over 3. Togona kusa reason, togona kungoti positive geometric progression. In your test, I would advise munonyora in full. Apa ndangozvitira kuti for the sake of convenience. Saka R yachashanda nayo ndiani? Ndi 1 over 3. And we have a reason for that. Now we have calculated what the value of R is. We have need to calculate the value of A. Saka kuti to calculate the value of A is going to be relatively easier, because we can take any equation, substitute 1 over 3 into it, and we get our A. Saka tangatine this equation, A plus AR is equal to 24. And then we want to substitute R na 1/3. Kureva kuti A plus A multiplying a third is equal to 24. Pana pateta kuti A plus chi, A over 3 is equal to 24. Tika simplify kuside kunoku inosara iri 3A plus A over 3 equal to 24. Saka 4A over 3 is 24. The reason why tatora R is equals to 1 over 3, taitsanangura. Kureva kuti even when we are doing our working, we do not take R as negative 1 over 4. We have disqualified that. Saka apo we are in need of knowing kuti 24 times 3 ndiani. Saka toda zauti 24 times 3, because tengeta cross multiplier, 4, 8, 12, 6, so it's 72. Saka patru kuti 4A equates to 72. Divide both sides na 4. Saka A inge equal to chi. 4 into 4 it's 1. 4 into 7 it's also 1. 4, 5, 6, 7. We have 32. What is 4 into 32? That is 8. Kureva kuti A inge equal to chi to 18. That is what A is going to be. Now let us go back to our question. Question yedu yaendera mberi chiti. Maybe let us read it afresh. A geometric progression of positive terms is such that the sum of its first two terms is 24 and the third term is 2. Let us read the part for the question. Find the common ratio, taiwana, it's 1/3, and the sum to infinity of this progression. So kana takuda sum to infinity hazvichanetsi because tinoziva originally kuti sum to infinity for a GP, kutoti sum to infinity for a GP kuresva philosophically speaking, because we don't have a sum to infinity of an arithmetic progression. So the sum to infinity, we know it's equal to A over 1 minus R. And let us bracket this formula because it's important. So we are going to apply this formula. Sum to infinity is equal to A taona kuti ndi 18 over 1 minus R taona ari 1/3. Saka this is actually equal to, it's 18 over 3 minus 1/3. Saka ino ingerichi 18 over 2/3, which is what? Actually ingeri 3 times 18 times 2 tikazvievaluator. But let me show you why nchidaro. Because 18 dividing 2/3 zvakafanana kuti 18 dividing 2/3, which is 18 times 3/2. Hence 3 times 18/2. Saka tichizvievaluator panapa, 2 into 2 ndi 1, 2 into 18 ndi 9, 9, 18, 27. So our sum to infinity is going to be 27. Tinenge tapedza. So this is how it is done. Let me just undergo a small rundown. Yezvataita panapa. Saka takatarisa that question, tichida kuita diagonalize. Taona kuti it's a geometric progression. Saka we have noted kuti it's a GP panapa. Ndobva taona kuti reading it zvanzi, a geometric progression of positive terms is such that the sum of its first two terms is 24. Saka we know that first term for a GP it's A. Kurauti second term AR. Zvichibva pakuti GP ngechiti A to multiply A yacho ne common ratio yova AR, then second term times common ratio AR squared and so forth. Saka panapa pataurwa zvichinzi the sum of its first two terms, it's basically A plus AR is equals to 24. Ndobva zvanzi, and its third term is 2. We know this formula. The nth term of a GP is AR to the n minus 1. Kurevei, kureva kuti it is going to be AR squared is equals to 2. We took the two equations, tikashandisa the method of equivalence. Method of equivalence, because of how it greatly leans on transitivity, tinogona kungoiti method of what? Transitivity. We can as well say that. And then we do our bidding. Theta our bidding. After solving, we eventually get to this quadratic expression which we solve by way of factorization. Ichitipa two values of R. We have to make a decision. Turn out we cannot take a negative value of R because taudziwa kuti the GP has to be positive. Saka taona kuti we take a positive value of R. Then taking this positive value of R, we used it to calculate the value of A. Now A na R ndo zvatazoshandisa eventually patanga takutsvaka chi sum to infinity in this case yatawana iri 27. But remember, sum to infinity of a geometrically progressing sequence is equal to A over 1 minus R. So this is all we had. If you want extra lessons, WhatsApp us on +263 71 521 3310. If you're in Zimbabwe, it's simply 071 521 3310. Thank you and take care.